Ubiquiti gives you some really great options for tweaking those Wi-Fi settings and making your system come alive. But private pre-shared keys, BSS transition, fast roaming, band steering, AP groups, channel widths, what does it all even mean? Well, that's what we're going to be talking about in today's video. When you compare the settings that you get inside the Unifi controller to that of, say, a typical router that you'd buy at Best Buy, there really is no comparison. The typical router has a lot of these features and stuff built into them, but they're not settings that you can actually go change. They're all predetermined for you. So when my newbies get into the Ubiquiti ecosystem for the first time and see just all the things you can change and tweak and edit, it can be a bit intimidating. So what I thought we'd do is get into the Ubiquiti controller Wi-Fi settings and break down what a lot of these mean so you guys can get in there and start tweaking your systems. Now here's what we're going to be covering today. Private pre-shared keys versus using something like multiple SSIDs. And we're going to talk specifically about VLANs and how they play into these two options. Fast roaming and BSS transition. Nice to understand what they do and the difference. Band steering, AP groups, channel widths, and meshing. And then once we get through all these, we're going to talk about how I typically set up my settings, and we'll go through a couple different scenarios and kind of break that down a little bit. And then I just wanted to point out, guys, there is a link in the description. It is a Reddit link, but it's really good. And it really breaks down some of the additional settings that we're not going to get to in today's video if you wanted to read about those. And I think it's a pretty understandable document, so that's why I linked it below. Now, a quick disclaimer before we get started. In general, I'm kind of an advocate for just leaving the default settings in place, especially when you're just getting started. Because I really do feel that in general, Ubiquiti's default settings gives you a nice, fast, reliable Wi-Fi network, and you really don't have to tweak a lot of this stuff to make your system work. So I have to let you guys know, and even says in a lot of the little information bubbles, that by tweaking some of these settings, you do run the risk of making devices not be able to connect to your network. And I'll try to go into that as much as possible and call out those risks, but just understand that you could make things worse. And so in general, if this is just something that you don't want to mess with, I will tell you that using the default settings works just fine, and typically is something I recommend, especially when you're starting out. But I think it's important to define some of these things and help you understand what they do, so if you did need to change something, you absolutely can. So let's get started. So I want to start things off by talking about private pre-shared keys versus using something like multiple SSIDs, and we're going to talk about how VLANs play into these. Okay, now specifically with a private pre-shared key, basically what that is, or what in layman's terms, what you can do is you can create one Wi-Fi name, all right? So you have this single Wi-Fi name, Tim's Home Wi-Fi, and then you can create multiple passwords or pre-shared keys that point traffic wherever you need. So when you search for networks in your house, you just see the one network, Tim's Home Wi-Fi. But depending on what password or pre-shared key you enter to connect to that Wi-Fi name will determine where the traffic goes. So you'd have an IoT password, you'd have your main device password, maybe you have a guest password, right? So you can use guest policies and things in that. And it sounds great, but there's some pros and cons to it. And depending on which equipment you guys have will really determine as to whether or not you guys can use this feature or not. And I'll get into that here. Then there's multiple SSIDs, and an SSID is your Wi-Fi name. You'll hear me use that synonymously throughout the video. I have always called them SSIDs, so that's what kind of rolls off the tongue when I'm talking about it. But we're basically talking about the Wi-Fi name that's broadcasting in your house. So I like the idea of having multiple SSIDs or Wi-Fi names, right? You have Tim's Home Wi-Fi for my main devices, and then I have Tim's IoT devices for those devices, and then I have Tim Guest. So I'd actually have 3 different names broadcasting, all with a different password, and we'll break that down. Now, before we get into that, I want to talk about VLANs just a little bit, just in case you're stumbling on this video and you don't really understand what VLANs are. So let's break that down a little bit, and then we'll circle back to this part and we'll talk about how they play into this. Now, I like a nice illustration. I think it helps paint the picture here. So I created a couple as we talk about VLANs, and hopefully this will kind of help you understand a little bit better about what they mean. So if you take a look what we got here, this is basically a single highway. It's 2 lanes, but it's just a single highway. And we call this a flat network. This is representing what you would get if you just went to Best Buy and bought a router. You plug everything in, there's one VLAN. It says no VLANs, but basically there's one VLAN or one network, and all of your cars ride in it. So whenever you connect to the Wi-Fi, if you plug into a physical connection, you're adding a car to this highway. Now I've kind of broke down the different cars here too. We have blue cars, which are representing smart home devices or IoT devices. And then you have red cars, and red cars are going to be your everyday, maybe your work computer, your cell phones, things like that. And in this scenario, they're all on the same highway. They're all traveling down the same road to get wherever it is that they are wanting to go. Now, there's pros and cons to this sort of setup. The big pro is that when you want everything to talk to each other, there's no simpler way than doing it like this. Everything, every car, every device inside this single VLAN can talk to each other. So when you're setting up your phone to be able to talk to smart plugs and be able to turn on the Christmas tree while you're at the grocery store, this is by far the easiest way to do it. However, there is a downside to it, and it's typically why people get into something like Ubiquiti in the first place, and it's where VLANs come in, and that's where we can separate that traffic, because what happens is these IoT devices that everybody keeps buying and putting in their house and just plugging in and connecting to their home network, they're really cheaply made in a lot of cases, and they have a lot of vulnerabilities. They're not getting updates all the time, and so basically you've just introduced something that has possible vulnerabilities into your home network, and it has direct access to the laptop that you do banking on. So if your house ever did get attacked or one of these things ever got exploited, you're kind of giving an attacker direct access. And we don't really want that, right? Attacker would still have to know what he was doing and all that other stuff, but at the end of the day, we don't even really want to give him the opportunity. We like to build in these layers of security that would make his job really, really difficult, okay? And so that's where we're going to introduce VLANs. All right, so when we talk about VLANs, we're talking about separating that traffic. Let me show you what I mean. So we're going to take the same network that we had, but we're going to implement some VLANs. So we have our main VLAN over on the left-hand side, and we've stuck all of our red cars over there. And those are going to be, like I said, our laptops, our phones, maybe a work computer, things like that. We're going to put them in their own lane, okay? And then we're going to create a completely new highway or VLAN or network, whatever you want to call it, and we're going to stick all of our smart devices in there, the Christmas tree smart plug, the thermostats, things like that. We're going to stick them on their own road. Now, from a network standpoint, the main VLAN is going to have one IP subnet, so they're going to be like a 192.168.1 dot something. And the smart device VLAN is going to have a completely different subnet. So those devices will get a completely different IP address, 192.168.2 dot something or 3 dot something, whatever we decide to set up in the parameters. Okay? Now, this is going to do two things for you immediately. One, you'll notice there's less cars on each of the roads, right? We've taken the same amount of traffic and split it up. So things can move a little bit more freely. Actually, it's kind of funny that in the network world, when there's congestion on just a lot of things happening, they actually call it a collision, which is why the highway analogy gets used all the time, because there's collisions on highways and there's collisions in the network. So by kind of separating your traffic, you allow things to run a little bit more clean. You allow cars to move more freely. You get faster throughput, things like that, okay? Secondly, you are giving yourself the opportunity to implement security. So day one, security isn't there. All these cars can still talk to each other even though they're on separate VLANs in a Ubiquiti network. That's how Ubiquiti does it. So you create these VLANs, everybody can still talk to everybody until you start implementing firewall rules. When you implement the firewall rules, that's where things start getting restrictive. And so in my courses, or not really courses, in my playlist, I have a Unifi for Newbies, there's a firewall video in there. We talk about how to make it so the blue cars can't talk to the red cars, but the red cars can still turn on the Christmas tree from the grocery store, that kind of thing. So you get the chance to implement security. This is going to make an attacker's job a lot harder to be able to get to that work laptop, especially if they're trying to take the approach of going through an IoT device. And that's why VLANs are really, really important. Now, when we flip it back and go back to our original subject matter where we're talking about private pre-shared keys and multiple SSIDs, the way you set it up will actually point to VLANs. And that's why I thought it was very important to cover this, so at least you had a basic understanding of what we were talking about there. So if you go back to the original slide we were looking at, we have our single Wi-Fi name with different passwords or pre-shared keys. And each one that you choose will point to a different VLAN. So password 1 would be for our red cars, and password 2 would be for our blue cars. That would be our IoT network, okay? The alternative to that is using multiple SSIDs or Wi-Fi names. So you got your Tim's Home Wi-Fi, and that's where we're going to put our red cars, and then you got Tim's IoT devices, and that's where we're going to put our blue cars. And when you authenticate with that network, you're pointed to either VLAN 1 or 2. Now, there are some pros and cons to using these two different types of systems. And I think when you point out this part here, depending on how much you want to play with your network, you'll definitely have a lot more flexibility with the multiple SSIDs, and we'll talk about that here. So quick pros and cons. So the private pre-shared keys, one Wi-Fi name, technically easier to manage, right? It's cleaner. But your APs are still doing work, right? They're still handling the authentication process behind the scenes, whether you have one name or not. So I don't know how much cleaner it really makes it run. That's really where a network engineer could get in and tell you that. But, systematically, it's supposedly cleaner and easier to manage. Allows you to assign passwords to different groups of people. That's where we kind of talk about our guest, right? You can have a guest password and be able to give them, the in-laws come into town, you just give them their password. They connect to the same network that you're connected to, but they have their own password, and then you can kind of drive where they can go or where they can't go, right? So this is kind of some of the downsides. And this is when I talked earlier, we talked about depending on the type of equipment that you had might really determine whether or not this was going to work for you. So this is as it currently states, November 2024, with Ubiquiti stuff specifically, is that currently they are not supported on 6 gigahertz devices that require WPA3 for your authentication. So basically, if you have a Wi-Fi 6E device or a Wi-Fi 7 device, this option is not going to work unless you turn off the 6 gigahertz channel, right? And the whole point of having that kind of defeats the purpose. So that's a real downside. I think it's going to be supported in the future, but no matter what I tried to turn on and off, I could not make my Wi-Fi 7 device use this. It just isn't supported as of today. All settings are shared across all of your passwords. So we're going to be learning today about these different settings that you can set inside your Wi-Fi networks. Well, if you use private pre-shared keys, you're setting it once and all of your devices have to share those same settings. So you can't set up the Wi-Fi settings for your IoT devices differently than you would set up for your main network, laptop and cell phone and stuff. And in my opinion, those are set up completely differently, and I'll show you that at the end of the video when we get into my settings. So I see that as a huge drawback. And also, if you're ever troubleshooting something, this is something no one will point out, but it's something when I was testing it, I found it extremely annoying. So let's say you're testing something, right? And you have to switch back and forth between the networks. So first you have to put your cell phone on the IoT network and get the device in there, and then you're switching back over to the main network to test to make sure you can still talk to it, right? With this sort of setup, that's kind of a pain because you have to go in and forget your Wi-Fi and then connect to it again, so it prompts you to enter your password, and then you enter the other password. And if you have to go back and test something else, you got to forget it again, go back, because our phones and devices are set to just automatically authenticate with the last password you put in. So it's a lot of forgetting networks, and I found that really annoying, okay? So when you get into the multiple SSIDs or multiple Wi-Fi names, this is the route I kind of recommend. There are some limitations, but this is the route I typically recommend. I like this better. To me, this is cleaner, okay? And it's easier to manage. And there's a reason for that, and you're going to get some visual separation on your network, okay? And I'm going to show you what that looks like here in a little bit. It also allows for better fine-tuning. You can actually set your main network differently than your IoT network, right? And so it allows you to tweak those settings depending on what devices are connected to it. That's something you lose in the other one we talked about. Probably the biggest downside is there's limitations. You can't go nuts. You can't, depending on which access points you have, you're limited to either 4 or 8 SSIDs that you can put on your network and tie to different groups and things like that. So there are some limitations. You can't go absolutely bonkers with it, but when you start getting into 8 SSIDs, you're making your network too complicated anyway, and I would recommend you dial it back. So those are kind of some of the pros and cons. And I want to show you, we're going to go into the configuration here, and I'm going to show you kind of where these settings are set so you guys can see it. All right, guys, so if we jump over into the Wi-Fi settings, I have a Cloud Gateway Ultra we're going to be using today. So I have some general settings in here that we'll use, but I wanted to show you this particular thing with multiple SSIDs, which is what I have set up here, right? My home Wi-Fi, my OT Wi-Fi, and I have a pool Wi-Fi, which will be part of our example here. But let's just go see about creating a new network, all right? So I'm going to click on New Network. We're going to come over here. I'm going to give it a name. We're going to use the example, Tim's home Wi-Fi, right, that we talked about in the example. And I could, if I put a password in here, this is using the multiple SSIDs, okay? Well, we don't want to do that. We want to look at the pre-shared keys, which is grayed out down here. So I got to click on Manual, and then I got to check this box. Now, notice I can check it. And the reason I can check it is because I don't have any 6 gigahertz access points connected to this network. If I did, this would be grayed out and you would not be able to use it unless you turned off 6 gigahertz. That was one of the downsides of using this. It just isn't fully supported as of today because of the security protocol. So Wi-Fi 6 forces devices to connect with WPA3, and you can see I don't even have, here we go, WPA2 and PA3. So when you work in the, that aspect of it, this might be grayed out for you unless you turn this off, which again, what's the point of having faster access points if you got to turn off the feature that makes them fast? So, but for today's video, we're going to go ahead and use it. You'll see that, you see how it grayed out there because I turned this on. If I put this back to WPA2, it comes back alive. So it's not working with WPA3, which 6 gigahertz forces you to use, and therefore that's why it grays it out. So if I click this option here, you can see, all right, let's enter some pre-shared keys for Tim's home Wi-Fi. So for our default network, right, that's we could make a Wi-Fi network for that, but let's just do our main network. VLAN 10 is what I have it called in here. So we'll click that, and we're going to say the password is just 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I hit add. Okay, so if anybody connects to Tim's home Wi-Fi and enters this password, they're going to be redirected to VLAN 10 or my main network. But we can add multiple in here. So let's say we have some IoT devices, which is VLAN 20, right? We're separating that traffic. And let's just say this is IoT 1, 2, 3, 4, 5, 6, okay? And we'll add that. By the way, if you ever can't remember a password, you can come in here and just view them, right? Which is nice. Same thing on the multiple SSIDs. So once that's done, then I can hit save. And if I go over into my Wi-Fi network, whoops, I need to add the Wi-Fi network here. We're going to get into some of these other settings as well, but I just want to do that. So right here, I have a combination of multiple SSIDs, and then I have Tim's home Wi-Fi, which is broken up of 2 different networks. You can see if I hover over the little I, and I can route things accordingly. All right, so that's how the pre-shared keys works. That's where you go to find it. And if it's ever grayed out, now you kind of know why. You got to make sure WPA3 is not turned on, or you don't have 6 gigahertz turned on, which forces WPA3. Those are the two big kickers. All right, let's continue. All right, guys, lots to do here, so let's keep going. The next settings I want to talk about are fast roaming and BSS transition. Now, these are really important settings, and they are designed to help devices or clients move freely around a home that has multiple access points. So if your home does have 2 or 3 access points in them, these settings are going to allow that cell phone or that laptop to roam freely in the house without being disconnected. So they're very, very important. Now, if you build on what we've already talked about a little bit, right, this would be less important in an IoT network, right? Your thermostat doesn't come off the wall. Your TV stays on the wall. Nobody's taking their dishwasher for a walk. It stays in the same place. So these settings would be less important. So if you guys like the idea of using private pre-shared keys and you kind of have this all or nothing, all your networks have to have the same settings, these would be ones that you'd kind of be on the fence about, do I set or not set? And that's why I like the multiple SSIDs. So I found some kind of analogies that help describe what each of these do and how they help with the process. So let's jump into that real quick. And sorry for a lot of wordy slides on today's video, but I think I want you to be able to kind of understand what we're talking about here and go back and look at this stuff. All right, so we'll start with fast roaming. Basically in the network speak, it's 802.11r, all right? We call it fast roaming. And this is the analogy. If you think of your Wi-Fi like a cell phone call or like a phone call, and you're walking around on that call, you may need to switch from tower to tower, but you don't want the call to drop, right? So fast roaming, basically in the network version of that, helps your device switch between access points, demonstrated as towers in this, smoothly without losing connection by speeding up the reauthentication process between the client and the AP. So when you walk around your house and you go from this AP to this AP, that client, that device has to reauthenticate with that AP every time. That's some of the inner workings that's happening behind the scenes. And so there's a multiple step handshake that happens every single time. Now with fast roaming, basically the APs pass along some of that information to each other, which takes those steps away from the client and allows them to authenticate a little bit faster. So it basically allows you to move a little bit more freely and roam quicker, fast roaming, between your access points because those APs are sharing information. Now this is a client-driven thing. Your client has to be capable of fast roaming for this to work. And this is also one of those things that if you have an old nostalgic laptop that you just keep holding on to that's really old, chances are it might not have fast roaming in it. And if you set fast roaming on your network, you could cause that laptop to have some authentication issues, okay? The client itself has to be compatible. Now the good news is most homes, you know, in the last 10 years or so, the clients that have come out for houses, new cell phones, new laptops, whatever, MacBooks, they all have fast roaming built into them now. So it's less of an issue. You might run into it if you're doing this in a small business where, you know, maybe there's some specific equipment that doesn't have fast roaming built into it. But for the most part, in today's world, most devices do have it. So you shouldn't run into it, okay? So that's fast roaming. Now let's look at BSS Transition, or 802.11k/v. So if you imagine your Wi-Fi is a neighborhood and each access point is a house, then BSS Transition is like giving your device a map of the neighborhood and making suggestions as to which house or AP will give you the best Wi-Fi signal. Okay, so it helps your devices decide when and where to switch from APs as you roam around, right? So fast roaming makes the authentication happen faster and smoother, and the BSS Transition basically makes suggestion to the client saying, hey, just so you know, your signal's better over here. You might be better off if you switch. But they're just suggesting it. The client has to actually make the leap. So down below you can see BSS Transition says, hey, you should move that at AP, and fast roaming makes that move quicker and more seamless. So you can see how these two technologies, on or off, whatever, individually or both set, you know, can make the roaming process more smooth. But again, you run the risk with older devices specifically where you could stop them from authenticating. And I'm guessing that most IoT devices don't have fast roaming built into them. So, you know, a lot of times I turn these things off in my IoT network, which we'll get to later in the video. So really important stuff. Sorry for the wordy slide, but I did want to kind of explain what these are because they're very important. Now let's go into the interface. Let me just show you quick where they are. They're just a checkbox. You turn them on or off. All right, guys, so we're back over into the Wi-Fi settings. I'm just going to grab a couple networks here. We'll go over to my home Wi-Fi here. So this is kind of my main network, my main VLAN, VLAN 10. And these are all grayed out, like I mentioned earlier. So you just have to click the manual button here to tweak those settings. This is if you just wanted to leave everything automatic. And I mentioned in my disclaimer, guys, they do a good job with what they have turned on or off typically on auto. But these are also good things that you can kind of come in here and check. So if you come down here, you'll see fast roaming right here and BSS transition right here. You can see I don't have fast roaming turned on, or it wasn't on by default. So I'm going to go ahead and just check that because I want my main network to roam. And so I'm going to just hover over these real quick. So improves client transitions between APs when they have a weak signal. Clients that do not support this feature may experience connectivity issues. So there's always like a little bit of a warning before you do that. And sometimes that's scary, right? But just kind of understand what your client is and you'll be fine. And then fast roaming, you'll experience connectivity issues with devices that do not support the 802.11-R Wi-Fi standard. So they don't even define it. They just try to scare you, and that's okay. But now that you kind of understand what it does, you guys can set this where it makes the most sense. They're just on or off. That's it. Check boxes. There's no tweaking the settings. So I'll go ahead and hit apply changes, guys, and we'll keep things going. The next setting I want to talk about is called band steering. And I have kind of a love-hate with band steering. I love what it does, but I've also had it cause some havoc and chaos a little bit on some networks and devices connecting. So let's get into it. So what is band steering? So when you think of Wi-Fi, you have to understand that Wi-Fi is communicating with your devices on multiple bands. There's 2.4 gigahertz, 5 gigahertz, and now recently they've introduced 6 gigahertz on Wi-Fi 6E devices and Wi-Fi 7 devices because, again, as we get more and more devices online, things are just getting congested. So 2.4 gigahertz, if you're thinking of the highway analogy, right? 2.4 gigahertz is a slower highway, right? 2.4 doesn't have as fast as speeds. With fewer lanes, there's less channels, but it can go farther, right? Usually 2.4 can blast through a house pretty good and you get good signal strength everywhere. So because of the fewer channels and fewer lanes, you are more susceptible to interference, which is why I put that in parentheses. So they introduced 5 gigahertz and now 6 gigahertz to help with this, right? Less congested, more lanes, it's faster, but because the signal uses a higher pitched frequency, it doesn't penetrate through walls as well as like 2.4. That's why 2.4 can go farther. It's a lower frequency, and so it can penetrate walls. These are faster, and so they bounce off of things and ricochet. And so typically, if you want to take advantage of 5 gigahertz and 6 gigahertz, you need to have extra access points in your house to allow that to happen because the signal doesn't go as far. Whereas if you just have a 2.4, you can usually put one router in the middle of the house and everything can connect, right? So what band steering is basically, it acts like a traffic cop, and it basically says to your device, why don't you try using the faster highway, right? Use 5 gigahertz or 6 gigahertz instead of the slower 2.4 if you can. So it's going to make that suggestion to your device in hopes that your device will take the hint and start using the faster channel. All right, so let's think about this here for a second, right? So you have this setting that makes a suggestion to the device to use faster frequencies in the house and therefore have better, faster speeds. Now, this is great from a cell phone standpoint or your laptop. You want those devices typically to go faster, and so making that suggestion to them, they'll usually say, you bet, I'll use the faster frequency, okay? And that's really great. However, when you go into the IoT world, most of those devices are fairly inexpensively made, right? And so a lot of them only come with 2.4. And that's okay because the amount of data that goes back and forth is very small. When you say turn on your Christmas lights with your phone, it just sends a little data to the device and the device turns something on, and that's it. There's not much stuff happening. Now, if you're streaming on a TV, a smart TV, there's a lot of data going back and forth. And so you want that to be faster, right? That's why they introduced some of these newer frequencies, because it would be very difficult if we were all trying to stream on the 2.4 gigahertz channel. And so, band steering is really great in that scenario. However, it's a checkbox. It's all or nothing. So it's either turned on or turned off. So if you have your TVs that you're streaming on and your smart plugs in the same network, you could cause problems. And I'm picking on the smart plugs here, guys, because I've had a lot of issues with them where if band steering is turned on, they will not connect to the network. And so basically when it makes that suggestion, the client has to accept it. But I think it just confuses a lot of these not smart devices, and so they don't know what to do. Or they'll connect for a little bit and then get a suggestion and disconnect while they're trying to figure out what the hell's going on. And so I just find that a lot of really cheap, smart devices like smart plugs struggle with the band steering turned on. Now, an alternative would be, if you have TVs and smart plugs in the same VLAN, the alternative would be to use SSIDs. You create a 5 gigahertz only Wi-Fi network, IoT Wi-Fi, that points to the IoT VLAN, so you still get the security, and you connect your TVs to that. Then your TVs are running on 5 gigahertz because that's the only choice they have. That whole network, that whole Wi-Fi network, and I'll show you how to do that here in just a second, is only 5 gigahertz. And then you can create an IoT 2.4 only network that is also on the IoT VLAN, okay? But it's 2.4 only, and then you can put all your smart plugs and dishwasher and things that aren't, that aren't capable of 5 gigahertz or don't need 5 gigahertz on that one. That's kind of the workaround, because if you just have band steering turned on, you're going to have problems. Now, you could turn off band steering, right? And just say, I don't care if you're a TV or a smart plug, I don't want you to be forced to do one or the other. You make the decision based off what you need. And a lot of times, smart TVs will choose correctly. They'll just pick 5 gigahertz because they're capable of it, but sometimes they don't. And so you might have a good streaming experience one day and then a lot of buffering the next, and that's just because when the TV re-authenticated with a network, for whatever reason, it chose 2.4 the next day and is getting interfered with, and you're just having a bad experience. So the best way is to physically connect that TV, which we talk about and boast about on this network or on this channel all the time. But if you have to use Wi-Fi, it's nice to be able to force your TVs to use 5 gigahertz, and band steering really helps with that. Just understand that it can cause really dumb devices like smart plugs to struggle, and that's what I wanted to call out on this. So let's jump in the interface real quick and I'll show you where these settings are at. All right, guys, so let's jump over to the interface here. Now, one thing I want to point out, again, we're building on what we've already talked about a little bit, but if I go over here and try to hit create new, it says you've reached the maximum number of WLANs or wireless networks per band, which is 4 for all APs, okay? And that's because I created some, multiple, I've reached my max. So we're talking about the downside to using multiple SSIDs is there's a maximum. You can go over your limit. And so in order to show you what I'm going to show you, I'm going to go ahead and delete this Tim's Home Wi-Fi that we created earlier. So I'm going to click Manage. I'm going to come over here and click that and choose Remove. Say OK. And now we're able to go ahead and create a new network. So real quick, I'll go over in the IoT network here, my IoT. Band steering is right here. It's just a checkbox, on or off, okay? And so if we hover over, it says forces compatible clients to move to the 5 gigahertz Wi-Fi band to improve network performance. You notice it doesn't say 5 gigahertz and 6 gigahertz, okay? So I've noticed they've moved the band steering thing around a little bit as 6 gigahertz has come into play. So the future of band steering might change a little bit, but because we don't have any 6 gigahertz devices on here and we only have 5 gigahertz, we can go ahead and check this box, no problem. So if I turn this on, it's basically any device that connects to my IoT Wi-Fi here will be requested to jump on the faster 5 gigahertz band, and therefore if it's a smart plug, it could create some issues. And so the alternative would be to do something like this, where we have my IoT Wi-Fi, and let's just go ahead and say 2G, okay, and then we'll just turn off 5 gigahertz. So now we have my IoT Wi-Fi 2G, or 2 gigahertz, okay, with this password. What do we set for a password? Okay, 1 through 9 and with a 0, okay. So I'm going to go ahead and say apply, and then I can create another one, my IoT, whoops, geez, if I could type, Wi-Fi-5G, it's probably not going to be exactly the same. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Don't ever use that password, guys. We're going to choose the IoT network, so we want it to go to that VLAN. And if I come down here, I can actually just make this one 5 gigahertz only, which grays out my band steering. Band steering is not needed if you know, I can't turn this on or off. Once I turned off 2.4, it basically just grays that out, okay? So this will be a 5 gigahertz only network. And so now we have my IoT 5G, my IoT 2G, and we can connect our smart plugs to those accordingly, which is kind of nice, right? So these are just examples of when you can kind of use the settings to your advantage to force devices to connect the way you want. This is something you just can't do in a typical router a lot of times, especially when you tie in the VLAN piece, because most of those routers aren't capable of it. So, but with Ubiquiti, you can see it's actually pretty easy to do this. And so that's where band steering is. Now, typically on my home Wi-Fi, I have band steering turned on. Now, this network is broadcasting both 2.4 and 5, and most of the devices I connect to it are 5 gigahertz capable, and they're smart enough to make that decision to say, yes, I'm going to use 5 gigahertz, and the network itself is going to recommend it to the client, so they pick the faster network. So kind of a cool setting. I'm glad we were able to cover it because I think it's important for how you guys set up your networks. The next setting I want to talk about are AP groups, okay? Now this is very common in businesses. That's where you typically see this a lot, but you can use this in a house. And so I thought it would be beneficial to go over it so at least you know it's there in case you want to work this into your scenario. Now, the big time I see using AP groups and where it really comes into play in a house is when you have indoor access points and outdoor access points, okay? Or maybe you have house access points and then you have an external shop that has an access point in it as well, all managed by the same system. You could have a shop Wi-Fi, so you have a shop Wi-Fi name and password out there, but you don't want the shop Wi-Fi name to broadcast in the house. So in a case like that, you would group the APs. You'd have your in-house APs in one group broadcasting these networks, and then you'd have this group of APs, maybe there's one or two out in the shop, and they're going to broadcast your shop AP. Or maybe it's a pool, you have a swimming pool, so you have outdoor APs, an outdoor AP for the pool, and you have a pool Wi-Fi name, but you don't necessarily want to connect to the pool Wi-Fi when you're in the house. So you can group those APs and create some separation. So let's get over to the slide real quick. I'll just read it real fast. So Unifi AP groups allow you to organize your access points into different groups so you can manage them more easily and apply specific settings or different Wi-Fi names to different APs specifically. So if you think of it like lights, right? We all have smart lights now. So it's like grouping your rooms, right? I want to, this switch turns off all of the rooms. This switch turns off just the bedrooms. This switch turns on the kitchen lights, whatever. And so you kind of cluster these lights into groups. This is the same concept. We're just going to do it with Wi-Fi networks and access points. So the example here I have is you have a pool SSID that broadcasts only on the outdoor AP that is by the pool and does not broadcast inside. So let's go over to the config. Let me show you where this is at, and we'll dive into this a little bit and then keep moving. All right, guys, again, continuing over here in the Wi-Fi settings. So you can see I created a pool Wi-Fi network. I did that earlier because I knew we'd be talking about this. And then we have our home networks, okay? So in this example, we want my home Wi-Fi, my IoT Wi-Fi 2G and 5G to broadcast indoors, and then we want our pool Wi-Fi to broadcast outdoors. So the way to do that is we'll actually go into, we'll start with the pool network here. So we're going to go into the pool one, and then we are going to choose broadcasting APs all. So right now everything is broadcasting on everything, or you can choose specific ones, or you can do groups. So I'm just going to go ahead, since we're calling this groups, I could do this way. I could say only broadcast on check these APs. But let's go ahead and create groups. So we're going to go in, we're going to create a group. We're going to call this one outdoor APs. Okay, and we're just going to check the outdoor one. We only have one, but that's okay. All right, and then we're going to go ahead and create a new group and call it indoor APs. All right, and we're going to add our indoor, but you might have 2 or 3 or 4. You just would check those. Okay, and so now we want pool Wi-Fi to only broadcast on outdoor APs. Okay, so, and it says 1, obviously we don't have a bunch here, but if there was 2 or 3 or whatever, that's where it would go. And so we'll just go ahead and set apply changes. And now this pool Wi-Fi, which actually I want to put this on the main network here while we're making changes to make it accurate. So now we have our pool Wi-Fi, which is still the main network. It's still that main VLAN So I'm still going to get the same IP address. I can still communicate with things. If I want to print from the pool into the house, I can absolutely do that because the network can still talk, but I'm on a completely different SSID, and I'm specifically tied to the outdoor access point only because that's the only access point that will broadcast this name. But I don't want my Mine Home Wi-Fi broadcasting on the outdoor network, so I need to come in and make changes to these as well. So I'm going to choose groups. I'm going to choose this is an indoor, and I'm going to say change. Okay. Then I'm going to go into my next one, my IoT, groups, indoor, and change. And I'm going to go in here, my 5G, indoor, and change. All right, so now, oops, I picked the wrong one on that one, didn't I? There we go. Now you have to pick a group. You have to pick something. You can't have an SSID not broadcasting somewhere, so it forces you to do it. So now you can see I got one broadcasting on my outdoor, and then I have a couple on my indoor, or just one, but you know what I mean. And so you can actually kind of pick and choose where your SSIDs are broadcasting. Now this is a really great concept. It just kind of helps with, you know, kind of forcing traffic to do, or forcing devices to connect the way we want. And so your circumstance may dictate whether or not this is an important thing to do, or if it's something where you just want to keep the same name everywhere, and when you go out to the shop, you're just connected to My Home Wi-Fi just like you are in the house. That's also another way of doing it. Where I've run into the pool Wi-Fi specifically is someone will go from in the house to out the house, and they're sitting out there, and yet their device hasn't roamed to that outdoor access point. You think that's an instantaneous process, even with fast roaming and BSS, but if the signal doesn't justify making that move, then a lot of times devices won't do it. And so you might still be connected to an access point in the house, and you'll have a bad experience. Maybe it's running slow or clunky or whatever. And so the only way you could force it would be to turn off your Wi-Fi, turn it back on, and typically it'll jump on that outdoor Wi-Fi. Either way, you're having to do some kind of extra activity to force your device to connect the way you want. By doing it this way, when you're outdoors, you just connect to pool Wi-Fi. When you're indoors, you're not connected to it anymore, and you can actually force your device to connect the way you want. And that's what these settings are here for, to be able to force devices to connect the way we want them to. All right, guys, keeping going here, let's talk about channel widths. Now, channel widths are really cool because they can technically make your Wi-Fi go faster. I see that question all the time. I ran a speed test and I'm maxing out at this speed even though I have a 1 gigabit internet connection, okay? You can fix that issue with channel widths, but I'm gonna throw out a little caution to you right now is that you can also introduce more problems to your network. The wider you make the space you're sending your Wi-Fi traffic, the more your other neighbors are going to overlap with your network, and you could experience interference. So depending on where you live may drive this decision a little bit. If you live in an apartment, I personally wouldn't set this setting. I wouldn't mess with it too much. There's just too much outside interference in an apartment building. If you live in a neighborhood like I do, chances are you can probably tweak it. And if you live in a rural area, you know, you might be able to go nuts with it because you probably don't have neighbors right next to you in that case. So just kind of understand there is a downside to doing this too, but it's cool because you can actually make your Wi-Fi go faster. So let's quickly go over the slide. I'm going to kind of just generalize what this means because it's sort of hard to explain, and then we'll go and show you where to find the settings. So basically, if you think of the lanes on a highway in our road, right? Different frequencies are going to have a certain number of lanes. So 2.4 has so many lanes, 5 gigahertz has so many lanes, and 6 gigahertz has so many lanes. And so basically when you're adjusting your channel width, you're adjusting how many lanes you want to use at the same time, right? If you use 10 lanes instead of 2, you can obviously shove a lot more traffic down 10 lanes much, much faster. However, as we're talking about frequencies and things like that, it means that you're using more of the spectrum. All these individual frequencies and channels, you're using more of them at the same time, which means there's going to be more overlap with your neighbors. Therefore, could cause some pretty bad interference. Now, the thing I will say is that when you create a Wi-Fi network, Ubiquiti chooses these settings for you, and the settings they choose, I will argue, they're probably a little safe, but Ubiquiti wants you to have both a reliable network and decent speeds. They're not just automatically picking the fastest speeds, right? They want you to have a good overall experience altogether. So they pick the settings they do based off of that. They're not going to pick the ones that make you go the fastest, okay? They want you to have a good setup. Now, again, depending on where you live, you can absolutely get in here and tweak these, and you may not have any problems. And just think about it. If you tweak them, you can always dial them back if you introduce some issues. But just understand that you could open the door to that. So let's dive into the configuration. Let me show you where this is at. All right, so channel widths are not really part of your Wi-Fi settings. They are an access point setting, okay? So you can kind of see down on this screen, though, all the sort of representing the lanes on the road and how much of the channel you're using. So you can see these wider ones down here are we're using more of the channel at one time. And so therefore, if someone else is using frequencies in this area, we can absolutely increase our chances of interference. Well, let's go pop over into an access point and I'll show you where these settings are set. So we're going to go over here. We're going to click on Unifi Devices. We'll just pick our indoor access point and go to Settings. And then we can come down here and you can see channel width right here. So because this is only, this AP doesn't have the 6 gigahertz band, we're only going to be able to set the 2.4 and the 5 gigahertz. But if I did have another one that said, you know, had 6 gigahertz, we'd have that setting in here as well. So, guys, my recommendation, honestly, even though you can set this to 40 for 2.4, I typically don't recommend, and I think a lot of IT professionals out there don't recommend doing so. I don't think the juice is worth the squeeze. I typically recommend just leaving your 2.4 alone. Where you're really going to benefit from speeds is from your 5 gigahertz, okay? So these are the default settings that Ubiquiti picked, which means my Wi-Fi has a max throughput of whatever this channel width will allow me to go. I'm probably not going to be able to do the fastest out of all of it. So to make this bigger, to basically use more of the lanes at one time, I just pick a larger channel width and I go ahead and hit apply, okay? That's only going to do it on this AP. So if I cared to do that out here, I would need to go into that access point as well and change the channel width there. So it's an individual access point setting, okay? And we'll go ahead and hit apply changes. All right, guys, so the last thing I want to talk about here before we get into how I set up my networks, which I've sort of touched base as we've gone along a little bit, is meshing, okay? So meshing is just something, I wanted to bring it up because basically it's a setting that I typically turn off, and I wanted to show you where it's at. So this is again in the actual settings of the outdoor and indoor access points. We're not in the Wi-Fi settings that we were earlier. This is an access point setting. So if you click on the access point and you go to settings, this is going to be right where we just were when we were adjusting our channel width. Now, meshing is really cool because it allows you to actually wirelessly mesh your access points together. However, my access points have a physical cable plugged in. They're plugged into the light 8-port PoE here, and so I don't need them to wirelessly mesh together. I'm going to use fast roaming and BSS Transition to make the roaming happen. I don't need them to talk to each other in a wireless standpoint from a meshing standpoint. So typically, if you have your devices physically cabled to get their power and their network connectivity, I recommend turning off meshing. I've had it where even though the access point itself was physically connected, when you looked in here, it would show that its parent device was another access point. Like it was talking wirelessly, like it chose that over the physical connection. And I don't know if it was a bug or if it was just something else, or maybe it was just telling me the wrong data, but I don't like to leave that up to chance. This also introduces the opportunity to create loops in your network because technically your access point can talk to the network in two different ways, through the cable or through the Wi-Fi, and that actually creates a potential networking loop. So I've seen stuff get disabled because meshing is turned on. So in general, my rule of thumb is if you have your access points physically cabled, like I do, turn off meshing, which is in the AP settings themselves. All right, so as promised, I want to just kind of take a minute here and go over how I like to set my settings. Guys, feel free to leave comments, argue it. I have a really lot of smart viewers out there, and so they'll always bring something, you know, to my attention and be like, oh, I didn't know that, or at least make me do a little bit more research so I can make an educated decision for myself. So thank you guys for that. I appreciate it. All right, so this is kind of how I did it. So I got rid of the 2G and 5G only. I'm going to go ahead and just change that to just my OT Wi-Fi. Okay, so here's a very typical scenario, right? So we have my home Wi-Fi, which is going to be our main devices on the main network. We have our IoT Wi-Fi, which is on our IoT VLAN. And then we have our pool Wi-Fi, which is also on the main network, right? And so we have them broke up into AP groups based off of, you know, what we did over in the video. Let's talk about the Wi-Fi settings I like. So, as I mentioned earlier, I like the fact that with multiple SSIDs, you can customize how each of these behaves differently. It's not an all or nothing like it is with the private pre-shared keys. So my preference is to use multiple SSIDs. Just understand there's some limitations on how many you can have, which we ran into a little bit ago. So on the My Home Wi-Fi, this is my network that is, you know, my laptops, my phones, things we're using and connecting and moving around. This is how I would typically set mine. So groups, if you needed it, I don't have any outdoor Wi-Fi, so I'll just leave that alone for right now. But if we go down in here, and this would be grayed out, so we're going to click on manual. I typically leave both bands on. I would have band steering turned on for this. I want it to kind of force that faster network channel or whatever frequency, so it goes a little faster. So I typically turn on band steering. I typically have BSS Transition turned on and fast roaming because, again, I know my devices. My devices are newer. I typically don't have any issue with that. And we talked about the cautionary stuff before. Now, we didn't talk about this setting, but I typically like multicast enhancement turned on as well. And like I said, if you want to read about some of this other stuff down here, that link I put in the description does dive into some of this, okay? Now, typically, I like WPA2/PA3. I like the idea of if a device is capable of WPA3, that we're good. So that's how I would have mine set. That's typically how I would do my home network that has different settings. My APs, if we go into those, I typically have my channel width set to 20 on 2.4, 80 on 5 gigahertz. I think it was 160 on the 6 gigahertz if I have it, and I have meshing turned off, okay? And you guys might notice too, band steering right here, you can actually turn on band steering based as an AP setting as well. It's off by default, but if you wanted devices connected to this specific access point, maybe the pool AP or something, you could actually prefer it right here as well, just so you know. So it's kind of in two places, and I leave everything else alone. So that's typically how I have my settings. Now, for my IoT networks, okay, remember these are devices that don't roam around the house very much. They don't need much speed. Now, in my case, I also have my TVs hardwired, so I don't have a need for them to be streaming and having to choose the right frequency and stuff like that. I've made that choice for them. And so I typically have the name and password, whatever groups, if you're going to have those. I leave on both frequencies. I like devices that can choose 5 gigahertz to be able to, but I don't ask them to. I leave band steering turned off. I leave BSS Transition turned off, and I also leave fast roaming turned off. Now, you might ask about these two, and again, argue me in the comments, but this is just things I've run out. This is all based off my personal experience, but I've had smart devices, even though they're stationary, they're sitting in an area in the house where they could choose this AP or this AP, and they'll kind of flip-flop. They'll kind of go back and forth, and it creates like a little weird, sometimes the device will drop and reconnect, and then it reconnects to the other AP. It can create a little bit of chaos. I've just found by having these settings off that it helps with that. I could be completely wrong, guys. Again, I'm not a network genius. I don't really get into the fine, network engineering aspects of why everything works the way it does. I'm just basing this off of my personal experience, and I've found that by turning off those, I tend to not have any issues because my devices don't roam. Now, if I'm wrong, throw it in the comments. I always like to learn from you guys. But again, that's typically how I set that. I would also probably put on multicast enhancement on my IoT devices because, you're AirPlaying to things and there's certain smart devices that might need that, Chromecast and things like that. So typically I'll put multicast enhancement on. And that's how I set my settings, guys. That's typically how I do it. And that's served me very, very well. Again, I live in a neighborhood. If I lived in a rural area, I might turn things up a little bit and dial them up even more because I don't have to worry about my neighbor's interference. Now, I create my own interference because I got test networks and my regular network and neighbors' networks and all this stuff happening in my house at all times. So this is just what's worked well for me, and I think Ubiquiti does a good job of keeping my devices connected. I really don't run into the issue of stuff dropping very often. All right, guys, that's going to do it for me. I hope you found this helpful. Again, I know it was a lot of information and some of the slides were very wordy, but I wanted you to be able to look back on them and kind of understand the concepts here, even without, listen to me talk. You can just look at the slides and it kind of explains things. So hopefully you guys found that helpful. Thank you for watching. If you have any questions or comments, as always, leave them down in the comment section. I'll do my very, very best to reply to you and answer any questions that you have or argue my standpoint on things. I find myself doing that from time to time, and I don't mind it at all. So I appreciate you tuning in. We'll see you guys down the road in a future video.